rotate.
लैंडस्केप में कर दो.
Okay.
Yes, ma'am.
Okay. Yeah. Thank you. Thank you so much. But then now I won't be able to see the meet screen, na?
No, ma'am.
Okay. Then I will be seeing only the PPT. Okay. 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 I'll
Yes, ma'am.
start. Because actually I was trying. हाँ पता नहीं क्या problem हो रहा है. Okay. So now the next module is data link layer. We have already completed with the physical layer and the initial introduction for the CCM. Okay. Just 1 minute. Okay. So the next OSI model layer is second layer, which is data link layer. Okay. Now, as we have already seen for data link layer, for any layer, it has to provide the functions or provide the what are the functions designed for that particular layer. It is like you have to provide the services to the upper layer and the lower layer. Now, in this case, for data link layer, which is the upper layer, it is a network layer. So, network layer, it has to provide the services to the network layer. Okay. Apart from that, we have seen that at data link layer, you are having frames. Frames are used as the data unit. Okay. So, whatever data it is receiving from the upper layer, that is the network layer, at network layer, it is receiving packets. Okay. Now, but at network layer, it is transmitting packets. Now, whatever data link layer is receiving packets, it has to convert it to the frame. We have already seen that for every layer, you have some header and trailer, which is attached to that particular data unit. Okay. So same way at data link layer also, there will be some kind of headers or trailers. Now these headers and trailers are some kind of control informations which are required for the pure layer. That means transmitter will add some data which is required for processing, and that will be received by the receiver data link layer. At receiver data link layer, that headers and trailers will be received, like it will be removed. It will use that control information for processing of the frames. And at the receiver data link layer, what it will do? It will transmit it to the network layer. At transmitter, the data link layer is going to transmit the frames to the lower layer, that is the physical layer. And at receiver layer, it is going to receive the zeros and ones. It is going to make the frame out of it. That frame will be having it will be having that header trailer, that information will be removed, and that frame will be transmitted to the network layer. And at network layer, it will be handling the packets. Am I audible properly?
Yes, ma'am.
Yeah, yeah. So the framing is one of the functions for data link layer. Now, next is like whatever data it has received. Say, for example, if the application, that is the user, is getting the data. Now, if there is no check in the network, whatever data is received, that is transmitted as it is. So, after receiving of the data at the application layer, if the user comes to know that the data which is received has errors, entire process has to be repeated. Okay. So, instead of that, there is a error control and error checking at every layer within in its own manner. The network layer will do the error checking, like if IP doesn't have that this thing, but we have some kind of other protocols, like later on you will see ICMP, where at least you get the messages that there is an error. So the error correction and error detection, basically error control, can be done at data link layer, so that uh, if the data is having any error, it is not passed to the upper layers. Okay, and it is the negative message is given to the transmitter from the data link layer itself. So the data is not processed and transmitted till the upper layer at the receiver end. Okay, so it has got the function of error control. So whatever headers and trailers it is transmitting, in that it will have some information which is related to the error detection and correction. Later on, we will see different methods of framing, different codes which are used for error control. Okay. So these all points will be explained in more detail later on. But right now, you just understand these are the basic functions which are provided by the data link layer. And these are the issues it has to handle. That is, it has to handle with the error. It has to handle the framing. So these are the data link layer design issues. Whenever you are designing that particular layer, these are the issues it has to face. Then the flow control. Flow control means what? What do you mean by flow control? Flow control is something like, say for example, the speed of every unit or every device is different. Okay, there are, say for example, your normal PC and the server. The capacity of the server is more, so it will transmit with more capacity. The data transmission will be, the data rate will be more. Okay, but the receiver is not that it is not having that capacity. So the receiver should not lose the data. Okay, whatever, say for example, the transmitter has transmitted 100 packets in some time duration, the same should be consumed by that receiver. There should not, if it cannot process that packets in that same time, it will lose the packets. So instead of losing the data, there is a slow receiver and there is a fast transmitter. So the time has to be adjusted, or it has to be processed in such a way that the packets are also not lost, or the frames are also not lost. And you have to keep the check of the data, something like the tap. Okay, so there are a number of algorithms which are used for flow control. So there is like it will control that fast transmission of the data or the frames and the slow receiving. So there will be some buffer or there will be some queues which will be provided at the receiver end, so that whatever frames are received, they will be queued or they will be buffered, and then they will be processed in the receiver's order. Okay? But they won't be lost. So there has to be some kind of flow control which is provided at the data link layer for managing the frames. Okay, so these are certain design issues that it has to handle with the services provided to the network layer, that is the upper layer. For the data transmission to the lower layers, it has to make the frames out of it, that is whatever data it is receiving from upper layers or from at the receiver end from the below layers. So there is a concept of framing. There are different methods of framing. It has to have the error control, that is error detection and error correction. And there is a flow control. Flow control means fast transmitter and slow receiver. They have to, it has to be like there should not be any data loss, and all the frames should be received by the slow receiver. Okay, so these are the functions of the data link layer. It has to provide the service interface to the network layer, the dealing with the transmission errors, and regarding the data flow. So slow receivers not swamped by fast senders. This is the same thing. So now here the functions of the data link layer. So we have already seen there is a packet at the, this is the transmitter. At the sending machine, you have a packet, that is a network layer. So network layer from the transmitter end will transmit the packets. At the receiver, at the data link layer, what is the function at in the transmitter end? There will be payload feed. Payload feed means whatever packet is given will be taken as it is, and there will be some kind of header and trailer which will be added, and it is going to make a frame out of it. That frame will be transmitted to the receiver. At the receiving machine, it is going to get that particular payload field, that is, it is going to receive the frame. It is going to remove the header and trailer which is received. This is a control information which is required by the data link layer itself. And that payload field, which is a packet, that will be transmitted to the upper layer, that is a network layer. So this is how it is going to convert the packet to the frame, and then again at the receiver end, frame to the packet. Okay, so this is one of the functions of the data link layer, that it has to make a frame. Okay. Now the next is services which are provided to the network layer. So services provided to the network layer. For this, you can see there are two. There is virtual communication and there is actual communication. What do you mean by virtual communication? Virtual communication is you have peer-to-peer communication. That is, you have the data link layer at the transmitter end communicating directly with the, you are assuming that these frames are directly transmitted. So you have virtual communication between the two data link layers. So you are assuming that this frame is transmitted directly to the data link layer, and that is a virtual communication. But actually, that frame is transmitted to the physical layer. It is converted to bits, and then it is again transmitted or again received as number of bits. Then it is transmitted to the data link layer. So this is the B part, is the, that is on the right side. You can see this actual path, which is the actual transmission of the data, and virtually you are assuming that data is transmitted between two different network layers. So this is the services provided to the network layer. Okay. Now this is the next services provided to network layer. So here you can see services provided to the, is it visible properly? Okay. Where is the placement of the data link protocol? Okay. Something like this is the layer 3. That is, you are having layer 1, layer 2, and layer 3. So when you are, where you can see the box, that box is the actually the, when you are entering the network, which is the physical layer. Okay, that is actual transmission medium. 3 is the network layer, where you are actually having the packets. You are processing the packets, and how those packets are, you can say, uh, routed. That is, the path is selected. Okay? So this is the router. In this router, 3 is the routing process. The boxes are the transmission lines to the router. And at number 2, you are having the data link layer process. So this data link layer protocol works between this uh, routing process and the actual data transmission. So there are frames and data link layer processing done after the routing is done. So framing, is the screen visible properly? Na? If there is any issue, you please inform me. Huh?
Yes, ma'am.
Yeah. So now we'll see the different methods of framing. So we have already uh, seen that there is a like framing is what? Whatever packets it is receiving from the network layer, it will be adding headers and trailers to it at the transmitter, at the transmitting end, and it will make a frame out of it. At the receiving end, from the physical layer, it is going to receive zeros and ones. And that zeros and ones it has to group together to make a payload. It has to remove that headers and trailers which are meant for the data link layer itself, and then remaining data, which was the packet actually, has to be transmitted to the network layer. Now there are different methods of framing. Okay, so basically this is the data link layer, what it will break the physical layer stream of bits into frames. So there is a continuous flow of zeros and ones. It has to know what is the boundary, what is the starting of the frame and what is the ending of the frame. So at the transmitter end, it has to send some kind of start bits and ending bits, okay, which will be removed by the receiving end. तो जैसे स्टार्टिंग लिमिटर्स डाल दिया, दिस इज द डेटा फॉर वन पर्टिकुलर फ्रेम, and that start bits and end bits will be added from the transmitter end, which will be removed from the receiver end. Okay, so whatever zeros and ones have been received, रिसीवर को जो बाउंड्रीज है वो डिटेक्ट करना होता है कि कहाँ पे एक फ्रेम चालू हो रहा है, कहाँ पे फ्रेम एंड हो रहा है. It can give the length count. There are different methods. These are the four methods. First one is length count, second one is special characters, third one is bit stuffing, and fourth one is special encoding. What do you mean by length count? Okay, we will see one by one methods. Okay, length count is something like, say for example, here you can see, okay, there is a frame. Is visible properly? Okay, say for example, you are grouping 5 characters together. Okay, so frame one will be with the 5 characters. So this particular frame will be having the initial, that is the first bit, will represent the number of characters which you are sending. That is the length count for one particular frame. So it will send 5. That means frame 1 will have 5 characters. So it will read first 5 and then it will take 1, 2, 3, 4. Okay. So 1, 2, 3, 4 will be grouped together. So 5 and 1, 2, 3, 4. This will be one frame. Now next bit, it will treat it as again the length count. So next is character count 5. So it will take 5, 6, 7, 8 and 9. These 5 characters will be taken together as one frame. It will remove 5 and it will 6, 7, 8, 9 will be one frame. That it knows that first is the character count and next is the data. Then next again frame 3. Now for frame 3, you can see this here you are having the variable. You can have the variable data for a variable data length for every frame. Not necessary that every frame will have the same data size. That is, if at the starting it has given 5, not necessary that all the frames will be of 5 character length. Here they have given first uh, field indicates 8. That means it will take 0, 1, 2, 3, 4, 5, 6. This 7, next 7 plus the character count 8. That will be for frame 3. Next is again 8. So it will take 8 characters and then it will form the frame 4. Now this is at the transmitter end. It is going to insert that 8 before the data and it is going to make one frame. At the receiver end, what will happen? The receiver frame will receive that particular whatever bits it is receiving. It will take the first character as the count. So it will take 5 and then it will take the next 4 characters and it will know that 1, 2, 3, 4 is the data. Now here, say for example, there is error in transmission. Yeah, this is how the length count is sent along with the data, and this is one of the framing methods. Okay. Now in this case, how the error control is done? Here error cannot be corrected, but you can detect the error. Okay, there are some methods in which you can correct and detect both, but there are some methods where you can just detect. and you can just detect the error and inform the transmitter that there was error. It cannot correct on its own. Okay, so in this case, say for example, here frame 1, 5 1 2 3 4, frame 1 is received properly, but frame 2 is, there is, instead of 5 you have received 7. So it will take 7, okay, 7 as frame 2, and then now a character count has reached as 1. Now this is the error. Okay, so this is how there is a, like, you can have error can be detected, but error cannot be, you can say this is, if this is the error, then this error will be transmitted as it is. Okay, so it will not correct it, it is, the receiver is not able to correct that particular error. Now if this is having any acknowledgement, then the negative acknowledgement will be given, but if the acknowledgement is not there, then the error, the data with error will be transmitted. Okay, so this is first method, that is sending the length count, but it will have, it can have errors. Okay, so first one is without any errors, and second one is with one error. There was one error, and because of that the entire data, the next following entire data will be wrong. Now the second one is the special characters. The second framing method is, you can have uh, reserved special characters added at the beginning and the end. Okay, so these special characters cannot be repeated in the data, and if they are there in the data, there will be some special sequence added. It is something like, all of you must have done some programming, say for example C programming. C programming सबको आता होगा ऐसा मुझे लगता है, ठीक है? Yes or no? All of you know the C programming, na? Hello?
Yes, ma'am.
C
Yes,
programming
ma'am.
आता है? Yes, yes,
Yes.
yes. So उसमें escape characters होते हैं. You write escape /n, you write /b, okay, /t लिखते हो, /n generally for the new line. ओके, तो अगर आपको स्लैश जो है वो ऐड करना है एज अ टेक्स्ट, कुछ अगर डबल कोट्स में आपको प्रिंटफ स्टेटमेंट देना है और आपको /n के बाद में आपको एक्चुअल स्लैश प्रिंट होना चाहिए, तो आपको क्या करना पड़ता है, यू हैव टू ऐड दैट एस्केप कैरेक्टर, आपको उसके पीछे और आपको स्लैश लगाना पड़ता है, सो दैट स्लैश इज नॉट ट्रीटेड एज अ एस्केप कैरेक्टर एंड इट शुड बी प्रिंटेड एज इट इज. तो आपको उसके लिए केयर लेनी पड़ती है, बिकॉज यू जनरली हैव /n एज अ स्पेशल कैरेक्टर, एस्केप सीक्वेंस आप उसको बोलते हो. तो अगर आपको वो एस्केप सीक्वेंस एज ए एस्केप सीक्वेंस रीड नहीं होना है एंड एज ए कैरेक्टर लेना है, तो आपको उसके लिए और स्पेशल कैरेक्टर ऐड करना पड़ता है. सिमिलरली, when you are having the special characters added at the beginning and the end of this particular framing method, if the same characters appear as the data, you have to again uh, take the you have to add them as a double, मतलब आपको उसको वापस एस्केप सीक्वेंस जैसा उसको कोट करना पड़ता है. ठीक है, so say for example there is a DLE STX, that is DLE STX is the beginning, that is data link escape start, and end is DLE ATX, that is data link escape end. तो हर एक फ्रेम के आगे पीछे okay, it is like you are having, say for example this is the payload field, this is the payload field, and you are having a header and trailer. So there is a flag added, you can see there is a flag added. So this flag is, a frame is delimited by flag bytes. Okay, and there is a byte sequence before and after adding. So there is a uh, original character. Say for example you want to send, you will be adding two flags over here. Okay, now if this same flag appears as the original character, okay, you will be adding one ESC, that is escape sequence before that flag. Okay, after stuffing. So this is how there will be two flags. The flags will be this DLESTX and DLEETX. Say for example, these two flags will be added at the as the starting and the ending. But if these flags appear as the data, okay, so there is a and B, two flags are appearing, then you have to add one escape sequence before that, so that it will be treated as the data and not the flag. Okay, so and if the same escape sequence also appears, you have to give ESC two times. Okay, so this is how you have to you will be having the uh, characters which will be special characters which will be added. Okay, that is the starting and the ending. So this is one of the methods of stuffing. So frame will be delimited by these flags. The next method is stuffing of bits, that is bit stuffing. Bit stuffing is something like whenever you are having a, say for example, continuous 5 ones or continuation में number of zeros आया, then you stuff one bit. Say for example 0 1 1 1 1 1 है and 5 times 1 आया, तो after 5 ones अगर 8 ones भी है, so that 8 ones, see sometimes what happens that how to identify whether there is an error or not, क्योंकि कभी कभी ऐसे होता है कि all the data is lost, so there will be a stream of zeros. Okay, there is no data, or there is a one continuously कुछ noise add होके वो continuation में 1 आ रहा है. तो हाउ टू आइडेंटिफाई वेदर इट इज अ प्रॉपर स्ट्रीम और नॉट. तो ट्रांसमीटर क्या करेगा, सपोज उसके पास ऐसे नंबर ऑफ वंस कंटिन्यूशन में आ रहे हैं, तो 5 से फॉर एग्जांपल दैट इज अ डिजाइनर issue, that is designer will decide after how many bits it has to stuff one or it has to cut that particular stream. Say for example, as a designer I have decided I will cut that stream after 5 ones. So after 5 ones there will be 1 0 which will be stuffed. At the receiver end that 0 will be removed and the continuation में जो 1 आ रहा है उसको continue किया जाएगा. So after this is the original data. You can say A is the original data, B is the how they are transmitted, and C is the as the receiver end. So you can see here there are number of ones, sorry, there are number of ones which are transmitted, there are number of ones which are transmitted. So number of ones जब भी transmit हो रहे हैं, after 5 ones it will stuff 1 0. Again after next 5 ones it will stuff 1 0. Again after next 5 ones it will stuff 0. So original data जो है वो A है, B is the data which is transmitted as a frame. ओके, एंड रिसीवर एंड पे रिसीवर डेटा लिंक लेयर क्या करेगा, जो 5 ones के बाद 0 है वो रिमूव करेगा, एंड ऐसे वो जो 3 zeros ऐड हुए हैं वो तीनों zeros रिमूव करके वो डेटा बनाएगा एंड दैट विल बी ट्रांसमिटेड टू द नेटवर्क लेयर. दिस इज द मेथड 3 which is called as bit stuffing. Okay, so now next is the special encoding. Now in special encoding what is done is, सी इट वोंट ट्रांसमिट. जैसे हाई लेवल है, जनरली हम लोग क्या करते हैं, जो वोल्टेज लेवल हम लोग करें डिसाइड करते हैं व्हाट इज 0 व्हाट इज 1. जब भी एनर्जी डिटेक्ट होता है तो दैट इज सम हाई थ्रेशोल्ड है. से फॉर एग्जांपल जनरली हम लोग लेते 5 volts. 5 volts will be 1 and 0 is like 0 to say for example some noise sometimes it may appear. तो 0.5 तक हम लोग उसको 0 ही लेते हैं. 0.5 से 1 ऊपर जाएगा तो वो 1 कंसिडर होता है. ओके, सो इट इज लाइक या फिर हम 0 to 1 कंसिडर करते हैं तो 0.3 से बिलो जो है वो 0 कंसिडर होगा, 0.5 से अबाउ जो है उसको हम 1 कंसिडर करेंगे. ठीक है, तो इट इज लाइक 1 and zeros are given by some threshold. It may happen that you just don't consider that zeros and ones like that. जैसे मतलब No energy means zero. And if there is a some threshold, above threshold कुछ energy है तो one. ऐसा नहीं कंसिडर करना है. Zeros और ones को आप क्या कर सकते हो? ट्रांजिशन. When it is transiting from 0 to 1, that is low to high, you can give it as 1. And when it is transiting from high to low, you can give 0. And then it will continue. मतलब जैसे first low to high transition हुआ तो 1 आया, that 1 will continue till you get the energy transition from again high to low. जब ये हाई टू लो हो जाएगा तो वो सिग्नल जीरो कंसिडर करेगा. तो इट इज गोइंग टू ट्रांसमिट दैट वंस एंड जीरोस लाइक दैट. समझ में आ रहा है आपको? वो जो है वो इट इज लाइक कंटिन्यूएशन का वन का स्ट्रीम. हाई एक हाई ही आएगा. देयर वोंट बी 0101 का ऐसा स्ट्रीम नहीं आएगा. ओके, एक कंटिन्यूएशन में 1111 ही आता रहेगा. व्हेन देयर इज अ ट्रांजिशन फ्रॉम हाई टू लो, देयर विल बी अ, वो जो वन है वो जीरो हो जाएगा. बाद में वापस जीरो ही ट्रांसमिट होगा जब तक उसको कोई लो टू हाई ट्रांजिशन नहीं मिल रहा है. ओके, और इट मे हैव हाई टू हाई दैट ट्रांजिशन. अगर आपने हाई जो है उसको जस्ट कट करके हाई टू हाई ट्रांजिशन किया तो दैट मीन्स फ्रेम एंड. ओके, so this type of, or you can have combination of all these. Okay, so you will be sending a signal that does not have a legal representation. हम लोगों का legal representation generally ऐसे होता है कि energy means one, no energy means zero. तो अगर आप कुछ अलग टाइप का रिप्रेजेंटेशन भेज सकते हो, that is also possible. So that is called as a special encoding technique. And you can have the combination of this, that is length plus frame boundary. So you can send the length count, plus you can send the frame boundary, plus you can have this type of combination of representation of data. Okay, so there are these standards, that is IEEE 802.4 जो है, it follows this above standard. There is IEEE 802.3 which follows this combination of all the above methods. Okay, so there are different kind of methods which are used for framing in case of data link layer. These are the four methods which are used for framing, and this is one of the functions of data link layer. Is this clear? Is there any doubt in this framing methods पे कुछ doubt है? Hello?
No, ma'am.
Am I audible? See, I cannot see the chat box. मैं मोबाइल पे एक्चुअली फर्स्ट टाइम ले रही हूँ लेक्चर. आई ऑलवेज टेक ऑन पीसी. तो मोबाइल पे मैं मीट का चीज नहीं देख रही हूँ, मतलब मीट का कुछ चैट वगैरह देख नहीं रही हूँ. तो अगर किसी ने चैट बॉक्स में लिखा भी है तो मुझे मालूम नहीं है. तो जस्ट स्पीक.
Yes, ma'am, it's clear.
Clear, no? So shall we move to the next topic?
Yes, ma'am.
Yeah. Now there can be number of errors. What kind of errors can be there? Like when we say error control and error detection, to detect the errors or to control the errors, to correct the errors, first we should know what are the types of errors. Now, previously there were all analog signals. Now we are transmitting zeros and ones. So lines are becoming digital. Okay, so in and compared to analog, the errors are less. You are using the copper wires for transmission, which is treated as last mile. Last mile means wherever there is a very hard regions to reach, it can reach there also. Okay. In wireless, when you are using wireless, errors are very common because the noise which is added is more. So errors are everywhere. They can come as a, like generally burst of errors are there. So you have to handle all these type of errors. So there are different kind of error detecting and error correcting codes which are used. Any error detecting or correcting codes you know? कोई बता सकता है मुझे? Any type of error correcting or detecting codes which you have come across? All of you must have heard about Hamming code.
Yes, yes. Yes, ma'am.
Yes. और कौन से कोड्स आपको मालूम है?
Shannon Fano code.
Pardon? Pardon?
Shannon Fano code.
Pardon? Shannon Fano? वी आर टॉकिंग अबाउट एरर कोडिंग. एरर कोडिंग. हम लोग सोर्स कोडिंग या चैनल कोडिंग की बात नहीं कर रहे हैं. रिमेंबर, हम लोग सोर्स कोडिंग या चैनल कोडिंग की बात नहीं कर रहे हैं, हम एरर कोडिंग की बात कर रहे हैं. ओके, पैरिटी बिट याद है सबको? पैरिटी बिट सुना है?
Yes, ma'am.
Parity bit हम लोग odd parity, even parity, so you add some parity bit, so there are certain parity codes. Okay, ठीक है. Okay, so there are error correcting and then some are error detecting, some are error correcting. Okay, so say for example there is a character, this is the character H. Okay, say for example when you are using a Hamming code to correct the burst errors. Say for example when you are using Hamming code, character H, how it is represented? It is represented in ASCII. Okay, so ASCII में उसका 100 1000 ये this will be the 7-bit code which is generated in ASCII. Now when you are using a Hamming code, what you will be doing is you will be adding this, like later on we will see how the Hamming code is generated. ये हम लोग डिटेक्शन एंड करेक्शन का Hamming code का एक like separate topic है आप लोगों को, तो that we will see later on. Right now I'm just giving you the idea that when a Hamming code is there, you add some check bits. So you can see here there are some bits which are added. मतलब ये 7-bit का जो ASCII कोड है उसमें 4 parity bits add हो जाएंगे and you will get this Hamming code. Okay, तो ये 100 1000 जो है वो parity bits जो है वो add हो जाएंगे and at the receiver end they will be removed. तो डेटा जो है वो ओरिजिनल डेटा वापस ट्रांसमिट हो जाएंगे and Hamming codes provide you the error correction also. Okay, so it is something like the 7-bit code plus 4 bits parity. तो आपको मिल जाएगा ये कोड which will be transmitted. Okay, so something like this. Then there is another method which is called as checksum. We will see these methods in detail. Okay, right now I'm just giving you the idea of which kind of codes can be used. So there is a method of checksum. You must have heard about, like there is a checksum which is added. Okay, so it is generated for the entire frame. Checksum is generated and that checksum will be added at the end, at the transmitter end, and receiver में जाके क्या होता है वो it will again calculate the checksum and it will find whether the received checksum is matching or not. If there is a mismatch in the received error, received checksum and the calculated checksum, it will understand that there is an error and it will report it accordingly. But if both the checksums match, that means there is no error and it can transmit the data to the above layer. Okay, so there is a checksum which is calculated for the transmitting at the transmitting end for the transmitter for the frame, and at the receiver end it will be recalculated and it will be matched. It's a concept of parity. Parity means there is a single bit will be appended or it will be added. Even parity means the total number of ones will be one, or parity even parity means total number of you take it like number of ones are even or number of ones are odd. So there are again different methods. There is a parity checker and there is a parity generator. Parity checker, what it will check? Even parity checker मतलब वो number of ones check करेगा, अगर वो 1 है तो वो 0 डालेगा. मतलब number of ones अगर even है तो वो 0 डालेगा checker में. And I'm sorry, चेकर में वो 1 डालेगा क्योंकि वो चेक कर रहा है, तो वो चेक करेगा. अगर जनरेटर है तो अगर इवन पैरिटी जनरेट करने के लिए 1 या 0 जो भी डालना है, अकॉर्डिंगली इट विल ऐड. So there is again a parity checker and parity generator. So parity bit is like it will calculate the number of ones, total even or odd, depending upon whether you want even parity or odd parity. Again, for error detection, you have CRC, that is cyclic redundancy codes. Okay, so there is a CRC which is using checksum that is used, and accordingly, whether the checksum we have seen that checksum is matching or not, accordingly it is going to report whether the received data is correct or it is having any error. Okay, now we will see this error correcting codes, detecting codes. We will come back to this topic again. Okay, but for that there is one topic entirely Hamming code, there is entirely CRC, there is entirely you can say parity bits. So that topic we will be dealing separate. Okay, so right now we'll go to the next topic, that is protocols. What is the use of protocol? As we have already seen, there are certain rules which are to be followed at the peer layers. That means some rules which will be followed by the transmitter data link layer, the same rules should be followed by the receiver and data link layer. So there has to be some agreed means of communication between the sender and receiver for reliability, flow control. Okay, so these are certain rules. These are there. They are called as protocols. Okay, समथिंग लाइक से फॉर एग्जांपल अगर आप एसिंक्रोनस ट्रांसमिशन यूज कर रहे हो कि सिंक्रोनस ट्रांसमिशन यूज कर रहे हो, सो अकॉर्डिंगली what are kind of start and stop bits which are added, what kind of framing methods is used, ये सब जो रूल्स है जो ट्रांसमीटर एंड पे फॉलो हो रहा है, आपको वही सेम चीज आपको रिसीवर एंड में करना है, क्योंकि आपको वही हेडर एंड कंट्रोल, हेडर एंड ट्रेलर जो कंट्रोल इन्फॉर्मेशन ऐड हुई है उसको that receiver has to understand, and again he has to process. So for that, the protocols are needed. This is the format of frame. Okay, we just have seen that there are number of things which are added, but actually this is the information, and along with that, there is a what kind of frame it is, what is the sequence number and acknowledgement. It means like whether it is an acknowledgement frame or whether it is a data frame. If it is a data frame, what is the sequence? Okay, we will see this sequence number, and if it is an acknowledgement, whether the acknowledgement is positive or negative. In acknowledgement frame, the information part is not uh, seen or it is not processed. Only the acknowledgement is positive or negative, that is seen. An acknowledgement for which particular frame? चार फ्रेम्स किया तो 1 2 3 4 4 के लिए चार एक्नॉलेजमेंट्स आएगा, तो विच एक्नॉलेजमेंट इज फॉर विच पर्टिकुलर फ्रेम, सो उसका लिए भी सीक्वेंस नंबर रहता है. Later on we will see all these things. Okay. We will see the detailing protocols in the next class. Is there any doubt till this particular point?
No, ma'am.
No, ma'am.
Okay. Okay, just 1 minute. I will just take the screenshot for the attendance. Okay. So So we have completed with this particular topic. So I'll stop here and we can leave the class.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Yeah,
Thank you,
thank
ma'am.
you. Thank you.
Thank you, ma'am.
Thank you.